Hello, welcome to the session. My name is Ian Alderdice. I work at Ciena in the optical microsystems business. We're here today to talk about management and control of coherent optical pluggables. The introduction of coherent DSPs into pluggable and performance module space has changed the pluggable game. Technology advances have brought increased capacity, increased performance, and more advanced feature sets, while fitting into smaller footprints and using less power. Performance modules have been available for a few years now and require advanced telemetry that is managed by proprietary interfaces. These are typical pluggables that are mounted to a host board in a transport system. Pluggable coherent modules have also been available for a few years, but use standard management interfaces like CMIS and MSA. And these modules can be plugged into transport systems, they can be plugged into routers, a wide range of places they can be plugged into. Expanding the existing management interface to meet the existing applications and the future applications is an ongoing effort. So what is a management interface? A management interface is the interface between the module host and the module. It's for the purpose of provisioning and monitoring the module. Provisioning would include things like provisioning the wavelength, provisioning the power, the application select code. Monitoring can take a wide range of forms. There'll be things like defects, performance monitoring statistics that could be counters like corrected bit errors, or observables like receive optical power. In addition to that, the Coherent has added additional monitoring for things like constellation. Within the optical space, there's many different standards groups. The management interface portion spans many of these groups. So in particular, we're going to talk a little bit about CMIS. So CMIS is the Common Management Interface Specification. This specification is owned by the QSFP-DD standards group. It's defined as a I2C interface. It uses a register-based memory map that uses I2C pages to manage modules. It's a very generic spec. It's meant to manage a wide range of modules. It includes the basic functionalities that you need for any module, things like state machines for bring up, application advertising, and then some of the basic monitoring of a module, the power, the temperature, and then into some of the more advanced optical specification or monitoring where applicable, depending on the module. So the other specification in the space is CMIS. This is the Coherent CMIS. Coherent CMIS was introduced by the OIF group, and it's built upon CMIS. CMIS defines a number of pages within its spec for different functions. One set of pages was set aside as reserved for Coherent. And CMIS fills in those pages. The first attempt at it, or the first release of it, is done on 400 ZR. Very specific to this application, but it's meant to grow. So beyond 400 ZR, we will see updates to CMIS likely that will grow into different application spaces. But it uses the same concepts, the same I2C page concepts, and within the specific Coherent pages. And what it adds to CMIS is the different items needed to manage a Coherent plug, things like FEC, analog performance. So there's performance monitoring statistics added, performance monitoring observables, different things like that. And when I say statistics, we get into FEC bit error rates, FEC corrected errors. You can get observables in the analog space like DGD or SOP tracking. So And then a little bit of coherent provisioning. There's not a lot in there for coherent provisioning now. That may change as things unfold. As I mentioned, it's based on the 400ZR. And the 400ZR is really a very simple application of coherent. You've got a single fixed line rate, same FEC, same rate, and only one line port. And on the host side or the client side, once again, one rate for 400 gig defined, and just the same rate, no change of protocol on the client side. Okay, so pluggable optical transceiver evolution. Really, the first optical or the first pluggables were simple EO converters, very basic plugs that would convert an electrical signal into an optical signal. That monitoring would be limited to probably receive optical power and a frequency monitoring. Over the years, those modules advanced, and we saw the addition of features, a sort of a progression of functionality through the years. Multi-rate modules were added, multiple data path modules, basic protocol monitoring for items like bit error rate, wavelength provisioning for DWDM modules. These all required updates to management specifications. So this has been building over the years. As the plugs become more advanced, the management interface to support these features has become more advanced. Now, the next generation of coherent DSP-based modules is a large increase in management complexity. We're moving towards multiplexing or muxponder type modules with more advanced feature sets. We're getting flexible line rates, flexible client port support, and that can be number of client ports or the port supported protocols in the clients. We're getting into Ethernet functionality where you can add monitoring functionality like LLDP snooping on your clients. For OTN based clients, you can start supporting features like GCC or TCM on the pluggable. And then a more advanced analog monitoring for things like constellation. So we've started the evolution of these coherent DSP modules and all the advanced feature sets and complexity that comes with it. Managing this is a challenge. As I mentioned earlier, the standard for CMIS covers a wide range of module capabilities. So things from simple AOC cables to complex 400ZR modules and the next modules beyond it all have varying management needs, but need to be supported by the same interface or the same specification. So a key challenge of a standard like CMIS is supporting this wide range in the same management infrastructure. A simple module may only require basic inventory. There might be a few dozen read-only registers for the inventory, and that's all the support you need. Where a complex module may require complex provisioning and monitoring that's covered in hundreds of registers. Right, so some of the considerations for advanced management interfaces. So as we move to these more advanced modules, we're going to be managing more complexity. We need to consider the bandwidth and type of physical interface. So today we have I2C and NDIO working at this point with the standard interfaces, but starting to push up against some limits, and will some of these advanced features drive us to higher speed interfaces like Ethernet. The advanced management interface, we're going to have more options for things like client provisioning, multiple client types, mixed client types, a wide range of possibilities on the client side. On the line side, provisioning, we're looking at variable line rates, variable line types, different baud rates, different constellations, the standards of transmit power and frequency, and then different FEC types can be supported on the line side. So we're starting to get into a lot of different permutations and combinations of what can be supported on the line side with some of these flexible coherent DSPs. As always, there'll be alarms required to be supported on these management interfaces. And as the number of ports and the number of supported client rates goes up, the number of supported alarms and defects is going to go up. We're adding performance monitoring metrics for coherent transmission. And a lot of this has been added in CMIS, but the future probably will bring more monitoring. Items like data path encryption will be brought into modules at some point. Will we be standardizing the approaches to do this, and how you manage the key management for these things will be a challenge. And then items like OTM multiplexing and the complexity and the large feature sets that come with OTM multiplexing. So an appropriate modeling language and communication protocol is needed to support this advanced feature set and the complexity that comes with managing this feature set. So today we have 400ZR CMIS, memory map structure, addressable registers, and shown a little snip here of some performance monitoring statistics from the CMIS document. And you can see there's a 64-bit register to read receive bits and a 64-bit register for corrected bits. And there's a number of registers that are all supported in that standard, all addressable registers. Looking forward, there are other ways to manage these bugs. They can be managed as an object-based system with an object language like Yang to model the modules. Sort of a container type module where you have attributes for the media or the line side, attributes for the hosted client side, and those attributes are managed. So provisioning of the line side might become a message with certain attributes being sent in and supported values. Monitoring could be a message coming out that lists the performance monitoring statistics and observables. These messages obviously would pass between host and module. The existing I2C and MDIO protocols and the definitions that we have in CMIS and MSA support a CDB, so a common data block that can be used to transport messages between host and module both ways. And then looking forward, maybe move to a more advanced messaging protocol like JSON strings over an Ethernet. So lots of possibilities for these future directions, and this is an ongoing effort to discuss where the direction this should go. Beyond CMIS, you can look farther to plugs that are network addressable. So instead of being managed at the host layer, the host mod or the host platform really just passes messages through. It doesn't manage them, and you can manage that in network layer. So this is a more of an advanced, future-looking concept, but as we advance these management protocols and specifications, you can look forward to possibility of a different way of managing your pluggables. All right, so for today, the key takeaways for this session. So with the CMIS, the industry's made strides to generate a management interface for 400ZR. That's a spec that's out there today. We'll continue to evolve that spec as new applications are applicable and needed to be updated in the document. There are challenges ahead for defining and standardizing management interfaces to support the new capabilities of the more advanced pluggable DCL modules. So as we move beyond simple coherent applications like CFP2 DCO or 400ZR into more flexible, the more flexible applications that these advanced coherent DSPs can support, the challenge of managing that, that's something that's in front of us. So options for this include moving away from sort of the low rate register-based interfaces and towards object-based, message-based interfaces and higher bandwidth physical interfaces to support the increased messaging. And then looking beyond that, we also have the possibility of network addressable ports and managing plugs from network controllers rather than just at the host level. So thank you for participating in today's session. Look forward to the Q&A session.
Thank you, Ian. Let me remind the participants, if you have questions, please put your questions in the chat part of Zoom, and we will read the questions to the presenter. If there are no questions, maybe I'll have a question for you, Ian. So the challenge is, first of all, let me say thank you very much. I really enjoyed the presentation. The pluggable modules, so we're moving quite along in terms of having monitoring and coherent monitoring, which is pretty good. But it sounds like what you're saying is that the complexity is increasing quite a bit, and having to have all of this monitoring at the local level or directly in the pluggable module becomes quite challenging. And so you're interested in exploring ways that we may actually move that off somewhere else. Is my understanding correct, Ian?
That's correct, yeah. And this has been an ongoing effort within the OIF team, where we have we meet weekly, and this is our big forward-looking project. So looking at how do you manage these complex modules in a more efficient way. And as I mentioned before, like we're managing register-based modules, we're running out of space. So one of the things I'm looking at today is actually the register space in CMIS to add a network path state machine. And of course, there's not much there for space. So I've got to go put it in a different location, and we've got memory fragmentation. And so that's kind of the general challenge is trying to make this more extensible for the future, make it more user-friendly. Kind of move away. The earlier versions of CMIS and MSA were based on simpler modules, and as things get more complex, we're just going to have to look at something I think a little more advanced to support those modules.
Right, and as we move in that direction, does that also support interoperability, or is that something that's, because once we standardize these things, then it helps for one vendor to, or many vendors to support the same?
That's correct. The goal would be a standard interface that all vendors could use, all hosts could use. And when we talk about, I mentioned message-based. That would be a message-based system that everybody would use on the pluggable vendor side and on the host side. And we would define those messages in a way that it would be a standardized interface.
And is there any sense that we're actually burdening the system at this time, meaning that there's some information perhaps that we need not monitor or at this time, or maybe we need not manage at this time?
Right. Well, and how much you want to manage in a module really comes down to both on the vendor side and the host side. This discussion is really about making it possible to manage a more complex module in a more advanced way. But you are correct. If you want to keep it simple, the existing interfaces will allow you to manage these in a simple way.
Okay. Are there any questions out there? I don't see any questions in the question and answer. So Ian, I think we'll stop there. I want to thank you very much. This is very enlightening for me and very helpful. So I appreciate your presentation. Thank you.
Yeah, thanks for having me.